Okay, we're going to start Chapter 8 with Section 8.1. A lot of this is going to be review or a combination of a couple of different sections that we've done leading up to Chapter 8. Let's run over here to rational. Remember, a rational number is something that can be written as a fraction. One thing we do have to watch out for is we are not allowed to divide by 0. So we have to make sure that b is not equal to 0. So there's times where you're going to need to identify that. Little factor review. Remember, we got to remember how to factor, and we'll do a couple of factoring by grouping as well. So you got to remember when you got the lead coefficient is 1, we can split the x's up, and we're looking for factors of what do you multiply for this? Add to this, -2. -7 works itself out. Again, what do you multiply for this? Add for this. Going to be 2 and 4. Don't forget about these special ones. This is the difference of two squares. Something squared minus something squared. Split up the x's. Split up 81 into 9 and 9. 1 plus, 1 minus. Remember, the middle term goes away. X squared minus 9x plus 9x, that's where it disappears. Minus 81. You can always multiply them back together in order to check your work. Remember, when we are canceling, we can only be canceling across multiplication. So if I have AC over AB, these C's can cancel out. When I have 3 times 2 over 3, that would be 6 over 3. I think we all understand that that is 2 over 1. And the reason that that works is that 3 over 3 is 1 over 1, and this is for multiplication. Please don't make the mistake of canceling these 3's out. You cannot cancel across addition. As you can see, this would be 5 over 3. And if I canceled that out, you'd get 2 or even 3 over 1, and that would not be the case. So please make sure that you're only canceling for multiplication. Simplifying. Let me see here. N cubed over n. Remember, you can cancel one of the n's out. This is like n over n, and you end up with n squared, right? 5 on top, 6 on the bottom, 1 on the bottom. Factor here. Take a 3 out. X minus 3. Take a 4 out. X minus 3. Now we get multiplication, get rid of those 3/4. Simplification. Been doing this for years. Please make sure that you check to see when we are going to be undefined. So, got a couple of examples here. I think you get the idea here. What can x not be? X cannot be 0. This guy over here, b cannot be -7. This guy over here, x cannot be -5. This one, you need to factor. So let's talk about factoring when the lead coefficient is not 1. Remember, you multiply a times c, and that's -10, and we ask ourselves, what do you multiply for -10 and add for +9? And we're going to need a positive and a negative. So we're going to need a -1 times +10. And then that adds up to +9. So these are my two things. And that's what my 9 is going to turn into. 2x squared minus x plus 10x. There's my 9x. It's -x plus 10x. And now I'm going to factor by grouping. Group, 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 group. Take an x out, 2x minus 1. Take a 5 out, 2x minus 1. My answer, I'm going to throw it up over here. Now take a 2x minus 1 out, and I'm left with, if I take a 2x1 out of there, I'm left with x. Take a 2x1 out of there, I'm left with 5. There's my factored form. So the idea was what would make this undefined, and my answer would be set them both equal to 0. X cannot be 1/2, add 1 divided by 2. X cannot be negative 5. So we have to factor the denominator a lot in order to determine what the denominator can't be. Okay, let's just do a couple of these. I think if we look at the top now, we're going to go 16 over 8. That's going to be a 2 on top. C squared on top, C cubed on the bottom, C on the bottom. 4 b's on top, 1 b on the bottom. I end up with 3 b's on top. This guy over here, 48 over 16, that's 3 on top. X and x squared, I have an x left over on the bottom. Y and y, they both disappear. Z squared and z, I have 1 on top. 3z over x. Here I'm going to want to factor the denominator first. What do you multiply for 21 and add for 10? 3 and 7. Now take a look. This n plus 3 cancel out, and I would get 1 over n plus 7. Okay, so we would factor this one, and we would factor this one. That would take a little time, and then I think one set of the pairs end up canceling each other out. Okay, in order to invert our binomials, like this is 36 minus x squared, got to remember, we like things where the x is out front. I can take a negative out, which will change the sign on both of these. So this will become x squared minus 36 over 5x minus 30. So if you want to switch things around, you can always pull a negative out. So now when I factor, I get negative. I get x plus 6, x minus 6, because that's the difference of two squares, over 5 times x minus 6. Now these go away. I'll be left with a negative x plus 6 over 5, and that's a fine way to leave it. That's just fine. You could also factor right away. 5 plus y, 5 minus y. That's the difference. Take an 8 out, y minus 5. This one seems to be the opposite of this one, so I can pull a negative out of that one and turn it into y minus 5. And then this one I could rewrite if I wanted to as y plus 5. So I made this one, I switched it around by factoring out a negative. Now these cancel out. Negative y plus 5 over 8. Same thing here, factor the top, factor the bottom, cancel out what you have in common. You can do those ones on your own. Multiplication, same type of thing. You can either multiply right away and then cancel, or you can cancel as you go. If you canceled this one as you went, I'd take 3 and make it into 1 over 2. I'd take 80 and make it into 40 over 1. I'd take 40 and make it into 10 over 1. So whole number wise, I'm left with a 10 on top. I have an n on the top and an n on the bottom. Goes away. I have p cubed on top and p squared on the bottom. P on top. Be 1 left. These would go away. A cubed on top, 2 a's on the bottom. Be an a and a b on the bottom. That's it. If you multiplied them right away, you would have to deal with bigger numbers. A lot of times it's going to be easier. So if you did 240 a cubed np cubed over 24 a squared b np squared. And then you could simplify this and it would simplify down to the same thing. This guy here, factor m plus 4, m plus 5. And now I can go m plus 4's go away. This m will cancel one of those. On the top I'll be left with 4m. On the bottom I'm left with 3 times m plus 5. There's your answer. More of the same. We're doing a lot of canceling. Let's go over to dividing. When we divide, if you remember back to your elementary days, we flip the second guy and multiply. So I'm going to leave this alone, 28a squared over 7b squared, and I flip the second guy, and now it's a multiplication problem, just like what we did. 28 is 4 over 1, 28 over 7. This is 5 over 3. So I have 20 over 3. I'm writing somehow here. A squared over a cubed. I get an a on the bottom. B over b squared. I get a b on the bottom, and we're done. Again, same idea. Factor as you go. I'd factor this as I went. I'd say 4 times y plus 5 over y minus 3. Flip the second guy and multiply. Factor as you go. So I put this on the top, put this on the bottom. Look at that. Boom, 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 boom. The answer is 8. Isn't that fun? What a great time. That's about it for 8-1. Same thing here. When you're dividing by in this manner, you can still do the same thing. Essentially, you're multiplying by the reciprocal on the top and the bottom, times c plus 2 over c squared minus 9. Now that flipped. And now we can factor and multiply. Okay, that's the gist of 8.1. Hope you enjoyed.